be calculated in this fashion. And here's the final practice task. So an annuity pays continuously at rate 1, and we have to calculate the present value of this annuity. So the 10-year present, the 10-year certain annuity has present value A10, and it can be calculated by placing here 1 minus expected value. Okay, let's write it down. So for task 6, bar A 10, and here is bar, and here is this value. Okay, so it can be calculated like the fraction of 1 minus exponent to the power of minus 0.5 over 0.05. This is our conditions given here. So our delta is over here, and pays until death 4 years. So we are using these values. So according to this formula, the present value can be calculated, and it will be 1 minus exponent of minus 0.5 over 0.05, and this value is 789 equals to, and the 10-year deferred annuity will be evaluated as the difference between a whole life and a 10-year temporary life annuity, with each annuity evaluated using insurance formulas. So what does it mean? We need to evaluate the bar AX minus bar AX, that 10, bar 10, like that, and this equals to the fraction of bar AX bar 10 minus bar AX over delta. So this is our formula that we are going to use. And what does it mean AX10? How can we retransform it? We can retransform AX10. Let me copy that and extend to this condition. So it can be retransformed as to the power of 1 AX10 plus AX 1 over 10. So let me 1 over the fraction I guess like that. So what does it mean? The first summand will be just like fraction of A bar A over 30 delta. Over 30 delta. Okay, and then the next one will be plus 10 EX over delta. So in the end, I'm not sure if I'm missing with delta actually, but still. So here in the end we can sum up everything, and our last AX from over here, this one AX, will be the A30 over 30 delta plus A, so here is not just A, here is A bar 10, like that. So here is the condition, instead of 10 there will be 30 over 30 delta. Okay, so let me finish over here and continue this sequence of equations over there. So what we have here, uh, 10 EX over delta plus A30 over 30 delta. That can be further transformed. So this will be the fraction of 1 minus V to the power 10, and in the denominator there will be 30 delta squared plus another fraction. Here we place 2V to the power of 10 over 3 delta, and the last thing is the fraction of 1 minus V to the power of 30, again over 30 delta squared. So this is what we replace. These values are replaced with correspondent, and we know that V10, V to the power of 10, hold on, this value is just the exponent to the power of minus 0.5. So this exponent is just this value. Okay, so V is known, then our last formula will be bar AX minus bar AX bar 10 So this is our last formula, and we just replace this sequence of calculations. Here 1 minus V10 we replace with this value over here, and 2 times this value, and where else? V to the power of 30, that means we take the cube out of that, and I think that's it. So 1 minus V10 plus 2 times V10 minus 1 minus V10 to the power of 3. So it will be V to the power 30. Delta is 0.05. So initially we just change that 30 times 0.05, here 3 times 0.05, and here again times 0.05 squared. So now we have only numbers and we can calculate everything using R. One minus that divided by that plus that divided by that minus so finally we got this 2.975. Okay, let me place it inside this formula. And the expected present value of the annuity is the initial 786938. So our expected present value plus that. So the answer for our task is 10.8, like that.